As we look at our fourth conic today on hyperbolas, we're going to focus first on classifying again. And here I have our 7 conic equations, and we're going to just very quickly go through and identify the key characteristics of each one that makes one a hyperbola, ellipse, circle, or parabola. The first one's a hyperbola, and the reason is you have 2 squares and they have different signs. The second one's an ellipse because they have 2 squares, they're both positive, but they have different coefficients. The third is a circle because they have 2 squares, both are positive with the same coefficients. The fourth is a parabola because it just has 1 square. The fifth is a circle because you have 2 squares and they both have the same coefficients, both -2. The sixth is a hyperbola because you have different signs in both squares. And the last is a parabola because you have 1 square. Now, as we talked about ellipses, we have a standard form of a hyperbola. That standard form is x minus h squared over a squared minus y minus k squared over b squared equals 1. And when the x comes first, the hyperbola is going to go sideways, like so. The other standard form of a hyperbola comes when the y is first. So you have y minus k squared over b squared minus x minus h squared over a squared equals 1. And this parabola is going to go up, this hyperbola is going to go up and down. So now below we're going to look at 2 examples of hyperbolas, one going sideways and one going up and down. Our first one has a center at point -2, 1. So I'm going to go to -2, 1. And my a value is 3. So I'm going to go out 3 to the right and 3 to the left. My y value, underneath my y, is a b squared of 4, so b equals 2. So I'm going to go up 2 and I'm going to go down 2. At this point, I'm going to draw a box around my points. I'm going to draw a box here and down and over and down. Now I'm going to draw a diagonal line through the corners of my box. A diagonal line through the corners of my other box. You may remember our critical thinking worksheet when we did this, as we draw our 2 diagonals. Now because the x squared comes first, this means our hyperbola is going to go sideways. And so a hyperbola is going to touch at this point right here, and it's going to approach our green line, which is an asymptote, and it's going to touch our hyperbola once again at that point, and it's going to approach our other green line as an asymptote. And then we have the reflective one on this side that's exactly symmetrical to the other side. So the actual answer is just the red portion of our graph. Let's look now at our value on the right side where we have the y coming first. Our center over here is +3, -1. Please realize that the x comes first. Underneath the y value, we have a b squared of 16. So that means b equals 4 and a equals 1. So I'm going to go to 3, -1. I'm going to go up and down 4. Right and left 1. And so we have a fairly small box. Very narrow, very tall, going up and down. Now I'm going to draw my asymptotes again through my corners. And an asymptote on the other side through my corners. Now this hyperbola is going to go up and down. So I'm going to start at my upper point, and I'm going to approach my asymptote on either side. I'm going to start at my lower point and approach my asymptote on either side. And the reason, once again, this goes up and down is because the y squared is positive and the x squared is negative. Let's now look at our examples and how to determine how we're going to complete the square and turn a conic that looks like a hyperbola into our conic standard form of a hyperbola. So just like with the x squared and the y squared, we're going to group them together first, making sure we have the positive one in the front. So -4y squared plus 8y equals 4. Our next step is to factor out the 25, just like we did on the previous problem. So x squared plus 4x plus blank minus 4y squared, and here's the tricky part right here. I'm going to highlight this in red. That's going to be a minus 2y plus blank equals 4 plus blank plus blank. By now you probably realize that our first blank over here that I'm underlining with a green line has the value 4, but we're not really adding the value 4, we're really adding the value 100. Our second blank, half of negative 2 is negative 1, squared is 1, but we're not really adding 1, we're really subtracting 4 because the negative 4 times the 1. That's the big idea here, and now we're going to write it as a binomial squared, so x plus 2 squared minus 4 y minus 1 squared, and this equals 100. Just like before, we divide everything by 100 to get our final answer. So our final answer is x plus 2 squared over 4 minus y minus 1 squared over 25, and this equals 1. So let's graph this after we identify our center of negative 2, positive 1. A is 2, B is 5. Here we go. Negative 2, positive 1. A value of 2, B value of 5. So we're very tall in this graph. So our box is going to be fairly tall, which means our hyperbola is going to be narrow or wide depending if the x's or the y's come first. Now we draw our asymptotes through the corners of our graph, of our box. Here we go, there's our asymptotes through the corners. And now we consider the x's come first, so it's going to go sideways, starting it there and approaching the asymptotes. The only real part of the graph is the red part, not the blue, not the green, but just the red. That's the only real part of our hyperbola. Let's look at a second one where the y squared is positive. We're going to group the y squared minus the 6y, then the x squared minus 4x squared minus 16x, and that equals 11. Now we're going to complete each square by putting in our blanks, realizing we have to factor out that negative 4. So x squared plus 4x. I want to emphasize that. That's a plus 4x because we factored out a negative 4. Hardest part of our problem really here today. And that's going to equal 11 plus blank plus blank. The first blank is fairly straightforward. It's just a 9 added to both sides. The second blank is a little bit more challenging. We're going to add a 4 there, but that's not really adding 4. That's really subtracting 16. So now let's finish this up. Y minus 3 squared minus 4 x plus 2 squared equals 20 minus 16, which is 4. One of the key ideas that you're going to realize is if the 4 does not go in evenly to the coefficients in front of the y squared and the x squared, you probably made a small error somewhere calculation-wise with your numbers. Because when we divide everything by 4, we should get an answer that looks very simple, very straightforward. And here the 2 4's cancel, giving us x plus 2 squared over 1 equals 1. My center here is negative 2, positive 3. The x comes first. My b value is 2. My a value is 1. So let's go to negative 2, positive 3, an a value of 1, a b value of 2. We have a very small box here as we look at it. Our asymptotes also going to have to go through our small box on both sides. There we go. And now, because the y squared is front on the problem, this hyperbola is going to go up and down. Remember, your hyperbola needs to approach your asymptote, but never touch it. It should be somewhat curved as it approaches the box in the middle. So there we go. There's an example of 2 different hyperbolas, one going up and down, one going sideways, depending on which value comes first. I hope this has been helpful in learning how to complete the square for hyperbolas and also how to graph them once it's in standard form.